Hi guys, Engineer Academy here, back with another video of Hamming code, how to do it and the basics of it. So, the Hamming code was invented by Richard Hamming in the 50s and is used for error detection and correction. Let's say we want to send a 4-bit number, but before we send it, we want to encode it using Hamming code, so the receiver can detect an error and correct it afterwards. For example, let's take the number 10, but in binary. That would be 1, 0, 1, 0. Now, first thing you should know, these bits are called data bits. There are also parity bits or control bits, which while encoding we will present them with question mark. Basically what happens is we merge the data bits and the control bits together. Yeah, so the first step is the two of the first control bits go first. Then one of the data bits, then the last one of the control bits, and then we write the rest of the data bits. Now we have our code like this, the important thing is to know which control bit controls what bits. So the first one controls the one himself, skips one, controls this one, skips, controls, skips, controls. The second bit controls the one himself and the one next to him, skips two, controls these two. The fourth bit controls, or the third control bit controls the one himself and the three next to him. So to write that down, the first control bit, as we said, controls the one himself, skips one, then controls this one, skips one, controls the 0, skips one, controls the 0. The second control bit controls the one himself, the one next to him, skips 2, and then controls the 1 and the 0. The third control bit, or the fourth bit in our number, controls the one himself and the 3 next to him. Now, as we have our control bits all set up, we can replace the question marks in our code with certain bits. So, if the number consists of even number of ones, the result will be 0, and if the number consists of odd number of ones, the result will be 1. So, the first one consists of odd number of ones, the result would be 1. The second one consists even number of 1, the result would be 0. And the third one consists odd number of ones, and the result is 1. So to replace the control bits with the question marks, the first one is 1, then goes 0, then goes the data bit, then the third control bit, and the rest of the data bits. So this is the number 10 coded with Hamming code. Now, if we were to receive this number and we know it's encoded using the Hamming code, we would want to decode it to be able to detect an error and correct it afterwards. So, for decoding, we use the same technique with the control bits, which are these ones. The first, the second, and the fourth in this array, which is the third control bit. So, let's write them down the same as we did before. So, the first control bit controls the one himself, skips one, controls the 1, skips 1, 0, skips, controls. The second control bit controls the one himself, the one next to, skips 2, and then controls the last. The third control bit controls the one himself and the 3 next to him. Now, the same rule applies here as before. An even number of ones in the number gives 0, and an odd number of ones gives 1. Here we have an even number that equals to 0, here also, and in the third control bit also the same. Now we write the number from the bottom to the top, 0, 0, 0, so that would equal to 0 in the decade system, which means we don't have an error in our code. Now if the number was, for example, 0, 1, 0, that would equal to 2 in the decade system, which would mean we have an error in the second place of our code, and we would correct it with an inverted version of the bit 0. Thanks for watching, guys.